Hey friends, this is Miss Regine from SOAR Educational Services, and today we are going to learn how to work with inverse of function and composition of function. So when you're given a function like this one is written as g of x equals 2x minus 3. If you're asked to find the inverse of this function, the first step is where you see g of x, it really just means y. So you change this to y equals 2x minus 3. So that's just a function notation, but it means y. And then the second step is to inverse your x and your y. So where you see y, you're going to put x, and here you put y. So you just do the reverse. And next step is to solve for y. So you're going to try to isolate y. So solving for y, we will do plus 3, and I'll just write it like this, x plus 3 equals 2y. So I move 3 from this side and move it over here by doing the inverse operation. So we have x plus 3 equals 2y. And now finally, we divide by 2, and we divide by 2, and you get y equals x plus 3 over 2. If we're writing it in function notation, it would be g of negative 1, and that is x plus 3 over 2. So that's your inverse function. Now, let's say they tell you to take that inverse function and plug the original function into it. So let's say we were asked to do something like this. Because I have done videos where we just do composition of function, but what if they say g of negative 1x? So they want you to plug that g equation into the inverse function. Let's see what happens with this. So we have our 2x minus 3. That's our original, but our inverse is x plus 3 over 2. So wherever you see x, you're going to put this equation. So x is going to be, so this x right here, you're going to put in 2x minus 3, where that x is, plus 3 over 2. So what we have here is, if we're trying to simplify it, negative 3 plus 3, that cancels out. So we have 2x over 2. Well, the 2 and the 2, they cancel out, and you're just left with x. So that's how you know. Like if you want to check your answer to see, well, did I find the correct inverse? This would actually be the check step. You would plug in your original function into the inverse of function. If you end up with x, then you know that you did it correctly and that you have the correct inverse. Okay, let me give you another one to try. So f of x equals 3 and 4x plus 5. So you can pause the video and try it on your own first. Try to go through the steps and then come back and check and see if you got it correct. Okay, so remember, step 1 is to change it to y. Step 2 is to reverse your x and your y. And step 3 is to solve for y, which this one, it's a little more complicated. Let me see, I will try, let's see, maybe we could try cross multiplication. So we're solving for y. So if we cross multiply, I'll just put this right here, equals 3. Okay, so I want y by itself. In this case, if I did 4xy plus 5x equals 3. All right, so let's see. We have 4xy plus 5x equals 3. Okay, we want y by itself, so let's move everything away from y. So minus 5x. So 3 minus 5x. And let me write it right here. So we have 4xy equals 3 minus 5x. And we can divide by 4x. So now we have y equals 3 over 4x minus, the x would cancel over here, so minus 5 over 4. So that would be the inverse of the function. Now this one, we can try plugging it in again to check. This one would be, so this was our original equation. Okay, and I'll even plug it into here and see, because everything should cancel out. So 3 minus 5, and we have, wherever we see x, we're going to plug in 4x plus 5. So I'll just try it on the top one, because it looks slightly simpler. And 4x over here, so let's see, 4x plus 5. Okay, so remember, we want to end up with x. So 5 times 3, we have 15, and we have 4x plus 5. And then our denominator, we have 12. Oh, this is, and then we have 4x plus 5. Okay. Now, for the top, we would have to find common denominator. If we have a denominator right here, 4x plus 5, our common denominator would be 4x plus 5. So I can change this to 4x plus 5. Now, if you recall, whenever you find a common denominator, you got to change the numerator also. So that means I have to multiply the numerator by 4x plus 5. And that would give me 12x plus 15. Now I can combine like term, but I can see in my numerators, I can combine like term. 15 minus 15, that will cancel out. So I have 12 over, okay, good. And then on the bottom, I have 12 over 4x plus 5. First, for starters, we can see our numerator and denominator, they are the same. So that gives us a 1. So if we also tried keep, change, flip, or multiply by the reciprocal, which is what you do when you have a fraction, we can say 12 4x plus 5 times 4x plus 5 over 12, and that gives us a 1. So when we try to plug in this function into that gives us a 1. Let's try it with the bottom one and see what that would give us. Because normally when it's an inverse, it gives us an x. So let's see. Okay, so this one we have 3, and then we have 12, and 4x plus 5 minus 5 over 4. Yeah, I did think the other one was less complicated. We can try to simplify this together first. So if we keep, change, flip, we have 12x plus 15 over 12 minus 5/4, common denominator. Okay, but yeah, we actually are going to get our x. All right, so common denominator is 12. And now we can subtract 15 minus 15. That is 0. So Now we have 12x over 12. Our 12 cancel, and yes, we are left with x. So that was the inverse of function. So I know that was long. I tried taking a shortcut because the other one did look very ugly and messy, but as it shows in math, a lot of time you can't take that shortcut, so you do need to plug it into your final inverse function, which is right here. But when you plug this original function of x into this inverse function of x, which it should be written like this, and wherever you see x, you plug in that original equation, you do end up canceling everything out, and you're left with x, so that means they're an inverse of function. All right, well, if you found this helpful, please remember to like and subscribe, and I'll see you next time. Bye.